Hello, this is Dave Evelyn with SunWize Power and Battery. In this video, I'm going to demonstrate how to select a suitable charge controller for your application. The first step is to go to sunwizepower.com. Next, click on Parts Online, which will take you to the SunWize Power web store. From here, select Charge Controllers. Here you see a long list of charge controllers that vary in size and in price from $15 to a couple $100. So the question is, how do you select the correct one? The first step is to know the voltage of your battery bank. Voltages are typically 12 volts, 24 volts, or 48 volts. Generally, industrial control applications are 24 volts, recreational applications are 12 volts, and on and off grid home applications are 48 volts. However, there are variations to that. The next step is to know the short circuit current rating of your solar array. To learn more about how to find out the short circuit current rating and other electrical specifications of a solar array, see our separate video, Calculating the Current and Voltage of a Solar Array. For this example, let's assume that we have a 24 volt battery bank and a 400 watt solar array with a 12 amp short circuit current rating. Then the next step in selecting the charge controller is to select the amp rating filters that are at or above the 12 amp solar array rating. So we'll pull down the filter selections and we'll select all the filters that are at or above 12 amps but not excessively larger than 12 amps, and we'll apply those filters. This will give a list of charge controllers that will work for your application. To further filter, select whether you would like a maximum power point tracking controller or a pulse width modulating controller. Both controllers are reliable and work well. MPPT or maximum power point tracking controllers harvest more power from the solar array. The downside is that they come at a higher price. MPPT controllers are more efficient than pulse width modulating controllers because they track the maximum power point of the solar array, which varies with temperature. MPPT controllers are particularly advantageous for solar arrays operating in cold weather. For this example, I will select a typical pulse width modulating controller. You'll also need to decide whether or not the charge controller will have low voltage disconnect or LVD functionality built in. I highly recommend LVD for almost all applications. Its function is to disconnect the load when the battery voltage gets low before the batteries are excessively discharged, causing premature battery failure. So I'll select yes to LVD and I'll apply these filters. The result is a list of charge controllers that will work for your application. From here, make your final selection by deciding whether or not the charge controller will have a meter or not have a meter, and by finding a charge controller that meets your price point. Thank you for watching.